Good morning, everyone. Today we are going to discuss about plate tectonics theory. Okay, the Earth's surface is in constant, powerful motion. Okay, continental drift, oceans expand, and mountains rise and fall over geological time scales. Okay, everything are moving and expanding and rising towards each other. Not a single portion on the Earth's surface is static. Okay. Now, first of all, in 1912, Alfred Wegener proposed a theory of continental drift theory. We have discussed the earlier video about the continental drift theory. He observed compelling evidence that continents were once joined in a supercontinent named Pangaea. Okay, supercontinent named Pangaea, and super ocean that is name was Panthalassa. There are some evidence of continental drift theory like geological fit, fossil distribution, geological correlation. All are discussed in our previous lecture. Okay, now, despite the compelling evidence, Wegener's theory was widely dismissed for a critical reason. He could not identify a force powerful enough to move entire continents. Okay, the scientific community asks what is the, this is wrong, what is the force? Okay, what is the force engine driving this drift? For nearly 50 years, this question remained unanswered. After that, to find the engine, that means the driving force, we must look beneath the surface. Okay, this is the depth 0 kilometer, 100 kilometer, and 700 kilometer towards the center of the Earth. Okay, this portion is known as continental lithosphere, then oceanic lithosphere, then asthenosphere. Okay, the lithosphere, the Earth's rigid outer shell, comprising the crust and uppermost mantle. It is not a single piece, but is broken into massive tectonic plates. Okay, continental lithosphere, thicker, 30 to 70 kilometer, less dense and granitic, and oceanic lithosphere, thinner, 5 to 10 kilometer, denser and basaltic. Then the asthenosphere, the semi-molten viscous layer extending up to 700 kilometer deep. The rigid lithospheric plates float and move upon this fluid-like layer. Okay, there is a lithosphere. This is lithosphere. These two portion, and this is asthenosphere. Now in this picture we have seen two plate. Okay, upon mantle. Okay, mantle, and this is a magma chamber in the asthenosphere. Okay, this is a direction of plate towards west, and this is a direction of plate towards east. If two plates moving towards from each other, different in different direction, their might ocean ridge is emergence. Okay, because the magma chamber will rise upward. Okay, in 1960s, geologist Harry has discovered seafloor spreading. He proposed the new oceanic crust is continuously formed at mid-oceanic ridges and spreads outwards. This provided the first plausible mechanism for continental movement. Continents were plugging through the ocean floor. They were being carried along as part of these larger moving plates. Okay, now the unifying theory is born, that is plate tectonics theory. First of all, continental drift theory, Wegener 1912, then plate tectonics theory 1960s by different geographers, and seafloor spreading Harry Hess in 1980s. In the late 1960s, building on the work of Wegener and Hess, scientists like Xavier Le Pichon unified this concept into the comprehensive theory of plate tectonics. It explains that the Earth's lithosphere is divided into a mosaic of plates that are constantly in motion, interacting at their boundaries and fundamentally shaping our world. Okay, these are some plates on the Earth's surface. Pacific plate, Nazca plate, South American plate, North American plate, African, Arabian, like this, Eurasian plate, Philippine sea plate, Antarctican plate. Okay. Now, where plates move apart, there are some boundary created. First of all, divergent boundaries. Divergent means to moving from opposite direction, moving in opposite direction from each other. Okay, plates pull away from each other, allowing magma to rise from the mantle and create new crust. Okay, this is the direction in opposite direction, and magma from the asthenosphere is rising upward and creates the mid-oceanic ridge. Okay, then on the other hand, a rift valley will also created in this process. Okay, key features: seafloor spreading, shallow earthquakes, and volcanic activity. Okay, in these divergent boundaries, some geographical phenomena are created, like mid-Atlantic ridge and Great Rift Valley in East Africa. Okay, separates the Eurasian and North America plates, causing the Atlantic Ocean to widen by approximately 2.5 centimeter per year. Then Great Rift Valley in East Africa, a continental rift where the African plate is splitting into the Somali and Nubian plates, representing the birth of new ocean. Okay, these landforms are created in divergent boundaries, that is, plates pull away from each other in opposite direction. Okay, then in convergent boundaries, convergent boundary may be oceanic continental, then oceanic, then continental. That means one oceanic plate and one continental plate, then one oceanic plate and another oceanic plate, then one continental plate or another continental plate. Okay, if oceanic and continental plate, one oceanic plate and one continental plate convergent, then deep sea trenches, powerful earthquakes, and volcanic mountain ranges may be occurred. Okay, for example, the Nazca plates subducting under the South American plate, forming the Andes Mountains and the Perusillian Trench. Then, when oceanic and oceanic two oceanic plates convergent towards each other, the deepest oceanic trench, volcanic and island arc will be emerged, and the formation of Japan and the Philippines. This is the example of convergent plate boundaries movement. Then continental, for example, Indian plate and Eurasian plate, creating the Himalayas due to movement of Indian plate and Eurasian plate towards each other. That is convergent boundaries, and Himalayas is rise. Then you create massive and non-volcanic mountain ranges. Okay, continental. These are some types of convergent boundaries: oceanic and continental, oceanic, continental. Okay, these are some example of landforms occurred by convergent boundaries plate movement. Now, where plates green past each other, transform boundaries, that is transform boundaries, they passed each other towards this, then towards this, parallelly. Okay, plates slide past each other along a fault line. This is the fault line. No new crust is created or destroyed. Key features: enormous stored energy is released, resulting in high seismic activity and frequent powerful earthquakes. Okay, there are some real world examples like San Andreas Fault in USA and North Anatolian Fault, Turkey. Okay, San Andreas Fault is Pacific plate and North American plate, created by Pacific plate and North American plate, and North Anatolian Fault, one of the world's most active and destructive transform fault. Okay, we get three boundaries: first of all divergent, then convergent, then transform boundaries, and each boundaries create different kind of landforms due to plate movement, that is plate tectonics. Okay, the ring of fire and world in motion. Okay, the vast majority of global seismic and volcanic activity is concentrated at plate boundaries. The theory explains why these events happen, where they do. Over 90% of the world's earthquakes occur along these zones. Okay, these red portions are the Pacific ring of fire. That means is a frequent earthquake zone. Okay, earthquake is occurs frequently. Mountain building, orogeny, that is also known as orogeny. There is a theory, orogenic theory. The world's great mountain belts like Himalayas, Andes, and Alps are direct products of plate collisions, sculpted by immense pressure and uplift over millions of years. Okay, they are not built in a single day. They need over a million years. Okay, a process representing our past, present, and future. The forces of plate tectonics have been operating for billions of years and continue to shape our plane today. Still they are moving, and still they are creating different kind of landforms, but the changes is very little. Okay, The Atlantic Ocean continues to widen. The Pacific Ocean is shrinking. The Himalayas continues to rise as the Indian plate presses into Eurasia. The Red Sea is in early stage ocean basin forming as the African and Arabian plates divergence. Okay. After all, that theory provides a framework not just for understanding Earth's history but for predicting its long-term future evolution. Okay. The theory of plate tectonics is more than a set of facts. It is the grand narrative of our planet. It reveals how the leaf feet of distant continents, the fossil record, the magnetic signature of the oceanic floor, and the violent energy of earthquakes and are all interconnected chapters in a single epic story of a dynamic and ever-changing Earth. Okay, this is the basic concept of plate tectonics theory. If you have any doubt or query, let me know in our comment section. Okay, don't forget to subscribe my YouTube channel. Thanks for watching. Thank you.